Alright, okay, welcome to this lesson with teacher Kamanga. In today's lesson in chemistry, we're going to look at a question that was extracted from 2021 GCE Science Paper 2, question number 2. Now, this question is coming from the topic separation techniques. So, the question is saying figure B2.1 shows a separation technique used to separate miscible liquids. Okay, so this is a separation technique that we are seeing in this diagram. Okay, so we are seeing there's a thermometer there, there's a condenser, fractionating column, there are gas beads there. Okay, all right, so that is the diagram that we are able to see there. So the first question is saying what is the name of this technique? What is the name of this technique? So now when you look at this diagram, there are some few indications that will enable you to answer this question. What we understand is that when you look at distillation, there are two types actually. So there's simple distillation and also there's fractional distillation. Now this one you'll be able to notice here that we have what we call the fractionating column, then we have the glass beads. So you need to understand to say this one is fractional distillation. Okay, fractional distillation. So our answer here, it is fractional distillation. So that is very, very important that we should be able to differentiate fractional distillation. Alright, okay, so I think that one is very, very clear and straightforward. Okay, let's come to the next one. We're saying what is the purpose of the glass beads in the fractionating column? What is the purpose of the glass beads in the fractionating column? So we're able to see these glass beads there. We need to understand the purpose is just to increase the surface area for condensation. So increase the surface area for condensation. Okay, to increase increase the surface area for condensation. Okay, so we need to understand that this one also it is very, very important that we understand. Okay, so this one just increases the surface area for condensation, provides a large surface area for the process of condensation. Okay, that we come to see we're saying why is the Liebig condenser kept in the slanting position as shown in the figure above? So why is the Liebig condenser kept in the slanting? So the slanting position that we are probably talking about, we're talking about this position here. This position here, it is slanting. Okay, so the reason as why it is slanting is that to prevent the distress. You're seeing this distress which is being collected there. Okay, we are seeing this distress being collected here. Okay, from this liquid that we are seeing. Okay, so it is being condensed from this part, which is the Liebig condenser. Now what we are trying to prevent as it is being kept in the slanting position is the same distress going back to the fractionating column. What we understand is that the distress should be moving in this direction so that it is corrected in that round bottom flask. So this is what we need to understand. So it just prevents the distress from returning back to the fractionating column. Okay. Okay. So the answer is to preventing the distress from returning back preventing the distress from returning back from the fractionating column. Okay, as simple as that. Okay, let's come to our last one. The question is saying apart from the mixture of miscible liquids, name two other mixture which can be separated using this separation technique. So apart from that mixture, we have also what we call crude oil. So crude oil can be separated by fractional distillation. We also have paraffin and petrol and kerosene mixture also can be separated, and also we have the separation of ethanol and water can also be used, this one. So crude oil, crude oil, that is our first one. Then we have also ethanol and water mixture. Okay, so we have a lot actually. We also have the manufacturing of whiskey. Okay, so we can still choose from there. So this is how this question was supposed to be answered. Okay, so what is important is that let's always be going through the questions so that we see how best we can provide the answers for us to be prepared for the exam. So this has been Teacher Kamanga with you. Have a blessed day.